Let's take a look at this problem. It says find an expression for f of x and state its domain. F is a function that takes a real number x, so we're going to start with f of x equals x, and perform the following three steps in the order given. 1, take the square root. So we take the previous transformation, take the square root of it. 2, subtract 13. So we'll take our previous transformation, the square root of x, and we'll subtract 13. Okay, that's an interesting one. Now this says make the quantity, so they're referring to this previous value, I'm assuming, the denominator of a fraction with numerator 4. So the telling us create a fraction, numerator is 4, and then this goes on the bottom. And that's our function. Now our domain. We got two conditions we got to consider here. One of them is that your denominator cannot equal 0. So when you do have a fraction where you have a variable in the denominator, your steps, you first set the denominator equal to 0. So we've got square root of x minus 13 is equal to 0. And then you want to solve for x. In this case, it's a radical equation, so I'm going to take negative 13 to the right side. It becomes positive 13. Our steps for solving a radical equation is, first step is get a radical by itself, which is what we just did. Second step is to raise both sides to a power equal to the index. Now, index is whatever number's in this slot right here, and if there is no number, it's by default 2, which means we're going to square both sides. Now, when your index matches a power, then they cancel each other away. So we got x equals 13 squared is 169. Now, this is the value it cannot be. X cannot equal to 169. If I put 169 into my x in my original function, I get square root of 169, which is 13. 13 minus 13 gives you 0. So we can't have that value. Now, even more than that, though, whenever you have a radical, there's a second condition. We cannot have a negative number inside the radical. And so what we do is we set whatever's inside the radical greater than or equal to 0 and solve it. Okay. Now this is already solved because x is by itself. Now we got these two conditions here, and we want to merge these together and come up with our interval notation. Okay, so now x cannot equal to 169, but it's every other value that's greater than or equal to 0. So we're going to start off. We got this right here. This is x is greater than or equal to 0. We got 0, comma, infinity, and we got a bracket there. Now we want to exclude the 169. So we're going to transform this. We'll go from 0 up to 169, and I'll put parentheses on 169. Parentheses means it does not include it. Union, and then I'll go from 169 to positive infinity. Again, by having the parentheses on 169, that means it excludes it. So this right here is our interval notation for the domain.